have we all had exposure to like a road plan? You got blueprint reading? Don't let me stretch too far. Blueprint reading, everybody comfortable with knowing what a cross section is? Is cross section? I'm looking for nods. Is that some kind of a new concept or? Okay, so this would be what we would find in a roadway set of plans. It would be in a development set of plans if you were building a Panera Bread standalone or a Wendy's or something. Anything in a parking lot, anything in civil work always will have some sort of cross section with it. So there's components of the cross section that we can kind of take a look at. Certainly everything up here is what? This is the new pavement. So all these descriptors are tags to whatever the element is. So we can see in the legend we've got pavement, we've got concrete, we've got granular, we've got curbs. So it's basically just describing what all those things are. And what is this? We've sliced through the road, right? Manny, go ahead.
Do you guys, like civil, do you guys follow division codes when you're doing the tagging?
No. How about, yeah, it's division codes typically are building, because you guys are doing that with some of the building stuff and scheduling. Yeah, when site civil stuff, we used to have an IDOT book. Manny, it follows the same process. How about this? This is the Bible, looks like a Bible. This is the Bible for roadway work, so this is the IDOT spec. It follows the same kind of components where everything has a section to it, but the numbers aren't like 1, 2, 3, 15, 16, all the divisions, but it follows the same premise, so that if we needed to look at concrete pavement, section 400 covers everything concrete-wise. So it's set up the same way, at least the specs are. But yeah, it's not, if you have a development job, usually those are like the master spec. Is that the term you guys know, or master spec or CSI master spec? Follows that. But yeah, that's how the divisions work. So in our case, we've got concrete pavement, we've got areas to build a ditch. So you guys can start seeing this now. If we were to start looking at, when we're talking about cuts, we know what's that gonna be a cut, right? We've got a ditch to take out. So that's going to be what would be known as a cut area. We're digging. We know that we might even be able, if the soils are pretty good here, that we can do this, and we can say we know we're going to need material to build up the road here. So maybe the cut in the red can get flopped over and be turned into green for fill. So the material, we're building a ditch, but we're also building up for the road. This is the concept of cuts and fills as it relates to earthwork, because that's what we're talking about first, is just earthwork. So what do we see in the outside ditch? This is going to be another cut, right? Mm-hmm. So we're going to work with a cross section today. One of the problem set that we're going to do is we're going to work with a cross section, and we're going to have to kind of figure out where things are and where things go. So that's the basic concept. That would be what it looks like when you take the typical section and turn it into a detailed cross section. So at this specific location, and how about this? Where is it called out? Do we see what stations it's at? I don't see the station, but this would be a cross section like we said when we have a road. So if this was what? West frontage connector, and the frontage connector had a center line, and it looked like that. And this might be station 15 plus 0, and this is 16 plus 0, 17, on and on. They will give us a cross section looking this way at each station, right? So as this progresses, always going to change, right? The earth is changing, the road profile might be changing, but the shape is probably going to stay the same in the road. But this is where we could find out what the road is going to look like, let's say, at station 15. So what kind of information can we pull off of this? Let's just kind of look at some of this stuff. So center line of the road is right here, right? What's the cross slope of our pavement? 2%. You guys see the 2% here? So the pavement is pitching out from the center line at 2%. So we've been working with 2%, right? 2% is how many feet I go up or down by how many feet I drop. So everything is based on slope. So if we knew the elevation right here at the center of the road, we could determine when I go so far out, how far down do I go, right? What is the shape of that pavement section if we start at the high point in the middle and it crowns out at 2%. So we have the information available on this print, because why? They gave us right here 54602. So that 54602, that's the elevation right there where the hand is at. So we can figure out what the road is doing. We can start thinking about calculating what is the elevation out here or out here where the road is at. So it's giving us the information to be able to do that. Now what happens on the shoulder? Shoulder's at what cross slope? 4%, right? So the shoulders have a little bit more pitch. The reason for that is you want to get the water off the road. That's why we're cross sloping the road that we are. So how about the aggregate shoulder? 6%, so even more. Let's get the water off the road. But what we can see in this is, this sets up the grades, and that's what we're going to be working with today. Is it sets up the grades so that we can tell the concrete paving company, here's where the center of the road is, here's where you need to put the outside edge of the road, so that we get this road at 2%. That's kind of the exercise. So a typical section gives us all of that, and we get to see the elements. You know, there's under drain. We get to see the aggregate, what's going underneath, what's the base of the road. Here in our ditches, we can either be given 6% cross slope, or what is this? This is 2 to 1. Sometimes you'll be given what is just known as a cross slope. So that ditch right there at a 2 to 1 slope basically says every time I go down 1 foot, I go out 2 feet. If I go down another foot, I go over 2 feet. So sometimes a slope is reflected like that, where it's just a 2 to 1 you'll see, or 2 to 1, 3 to 1, 4 to 1, different slopes. But that's what that is. So we have the ability to now basically take this elevation, we can get to here, we can get to here, we can get to here. Now what 2 pieces of information do you think I need to tell the paving contractor where this point is? If the contractor said, I need you to do AEC 125, construction staking. If I needed our group to stake that point, what elevation, do I have enough information for us to calculate it as a group here? Could we do it? Paving contractor says, I need you to tell me what elevation that outside edge is at. Is it already there?
Doesn't it give us?
It's already there, right? How did we get it? How did we get that?
The lane width?
Go ahead. Yep. Manny said you got center line, right?
Right above the line.
Yep. It is. How could I check it? How could I check that the 545.78 is the right number? How could I do that?
You can look at the percent of the slope from before and then look at the elevation.
Yep. You ever see what Crystal's seeing?
Mm-hmm.
So if I know the center line of the road is at 546.02, it's going away at 2%. What's one more piece of information that I would need? Do I need to know how far away it is? The length or the width in this case? So it's probably 12 feet. That lane's probably 12 feet. So if we think that this grid right here, and I don't know if I have the scale on the sketch or not, but if this is a 10 foot between the dark line and the dark line, 11 feet, 12 feet, grab your calculators real quick. If you took 12 feet at 2%, 12 feet at 2%, so it's 12 feet times 0.02, what do you get? 0.24, right? 0.24. What is that 0.24? What unit is it? 0.24 what? Inches, meters, feet, inches, meters, feet, 0.24?
Feet.
Be feet, right? Because we're working in decimal feet. So if we said we had 12 feet and it dropped 2%, so it's 0.24 feet. So what do you do if you take that 0.24 feet and you subtract it from 546.02? 546.02. What do you get? 545.78, so it works, right? So that says we've basically checked, or we've calculated what the drop is between the center line of that 12-foot lane. So being able to use that percent slope and the width, if you know the lane width and you know the slope, you can calculate the difference in elevation, right? That's how this cross-section is then developed. So what would happen then if somebody said, hey, this shoulder out here, what grade is this? How could I find that? And if I knew that this is 8 feet, let's just say, because I'm counting 1, 2, 3, 4, 5, 6, 7, it's 8 feet. So the shoulder is 8 feet wide, and it's at 4% slope. What do we do first? 8 feet times 0.04, right? 8 feet times 0.04.
0.32.
0.32. So the shoulder drops from high to low, 0.32 feet in 8 feet. So what do I do with that now? I can take what?
1.2 minus
Yep, 545, 78, and subtract it.
54546.
Yep, 54546. So that's the outside shoulder. So that's the process. That's the process. We're going to use that today. So you're basically just using the widths and the percentage to find out where you started and what you need to get, how you get to where you got to get to. So does that make sense? Kind of. It seems intuitive, but that's how we calculate grades. Now a lot of this stuff is all electronic. A lot of this stuff is all CAD based. A lot of this stuff is put something really cool into a piece of software and it pumps all this stuff out. But the basis of understanding how the numbers come together, this is what we're doing. Yeah, Manny.
Do machines tie into this? Like when you're paving? Do they have like computers that?
Yeah. Yeah, and right now what is a huge thing in the industry, especially with pavings now, is automatic grade control, to where GPS units are set along the road that are doing all this constant communicating, and they're talking to the paving screed, and it's actually making the paving screed make the adjustments to where the edge of the lanes are at. So there is so much technical stuff that is going into paving, particularly now, grading, dozers, anything that grades, blades, can run off of machine control. If you guys like doing that, that's a career in itself of being able to work machines, but understanding how this technology works. It's really starting to gamify. It's gamifying the operator's role anymore. They're still craftsmen. They still have to pull levers and move machines, but it's getting to the point where the computers are so powerful that understanding how the software behaves with the machine makes those people just awesome. It's just awesome.
So like when you see a dozer or something, like you'll have a surveyor, basically he's got the stick with it looks like a plate.
Mm-hmm.
If you look on their blades, they have them on each edge.
You got it.
That's
it's all talking. Yeah, the GPS receivers now can sit on the tips of the machine. Sometimes they're on the top, but that basically is just doing the same thing as what a GPS instrument is doing. It's bouncing off satellites, it's reading things in real time, and it can make the adjustments. If the three-dimensional model is built and then put into the computer system in the machine, it now can go where it needs to go. I mean, it's just...
You just started up and sit there.
It's a trip. It's a trip. I mean, and being really good. I mean, that's why just operators that understand technology, it's like a double. You know, the older generation, they're craftsmen and they can move a blade just with their hands. But now it's getting to the point where the grade control can do it.
How hard is, well, obviously getting into Local 150, but like within itself is hard, but being accustomed to these computers and these GPSs, do you have a better advantage of getting in?
Oh yeah, for sure. If just being able to say that you've had some survey experience or have some exposure to GPS, then it starts to click. Yeah, Manny, I really think that's, and I think the industry-wide issue is the labor force and getting young people into dirt work, any kind of just hands-on stuff. They're screaming for that. So now it's to the point where if this is something you enjoy and there's a technology bent that goes along with it, because your generation's you're on the tip of the spear right now in understanding this. So to be able to work yourself into something like that, it's people are screaming. Yeah, 150. I think this area is unique because there's so much going on, but broadcasting around the country and that contractors just need help. They just need people right now. It's a great time to not only be in your profession of getting into this role, but anyone that likes to work with their hands in the trades and that, it's the same. Derek, I'm not preaching, right? It's true. I mean, we need help. The trades need help.
I'm looking for a carpenter right now.
Trades need help. It's true. It's true. Good, okay, well, hey, I like these little tangential conversations. So let's, maybe right along with it, so here, this would be just a quick shot of how grades might be set, lath to an outside ramp pavement. You know, when we're talking about what is this line, how did we establish what this edge of pavement line is, what elevations it's at? We just went through kind of calculating the numbers of how that could be done. But if we had a computer model, obviously, and the machines can run, then they do. A lot of times with edge of pavements, they'll always leave, and we've talked about lath. We've got them in the back. You guys will work with some of this, hopefully when we get a little warmer out. You know, this establishes the line. This establishes the distance. If I'm just going to arbitrarily say this is probably 4 feet, you know, you'll put a mark at 4 foot to the edge of pavement. It's a check so that you know where your running line's at. The lath will have the station